We're actually going to talk about the power of Solr metrics. So let's dive in. So what I'm going to talk about, my name is Andrzej Białecki. By the way, I've been a Lucene user and committer for the last, I think, 15 years or so. And we are going to talk about the motivation. Why do we need metrics in Solr? And how do we actually design this component, this framework in Solr? We are going to discuss shortly how it's actually implemented and how it can be configured to get the best out of it. And I will show you a couple of examples how the actual metrics look like both when they are accessed directly from Solr and when they are exported to external systems. And then I'm going to briefly talk about the future development in this area. So let's start with the motivation. Why do we need metrics? You could say, okay, I have logs. I can always SSH to a box. I can grab through logs. I can do a ping request and measure the response time. Well, let's face it, all of these are very crude methods of measuring how the application actually behaves. So we need something that is much more fine-grained, much more accessible, that will help you to troubleshoot various other problems that are not always so obvious. Like, for example, file descriptor leaks, or problems with heap usage or permgen usage. Especially, this is important if you have a lockdown deployment and you can't easily SSH into a box, or if you run a 10,000 node cluster and it's not practical to SSH into each box, isn't it? So you could say, okay, I could use probably profiling, but it's, again, not practical to profile an application that is in production. So we need something much less invasive, but at the same time that provides us with much more information. So hence the metrics. There has been a Jira request, Jira issue, to add detailed metrics to Solr. It's a long-standing request. It was first created in 2013. And there have been many contributors over these last 4 years. Let's say that currently the Jira component, which is sort of a group in Jira that groups related issues, has approximately 60 issues that deal with metrics. The two key Jiras that started the ball rolling was the initial framework, that's Solr 4735, and 9 and 12, which was adding the admin metrics handler, which is the primary way how you can access the metrics in this pool scenario where you want to retrieve individual or all metrics from Solr. The framework was first released in Solr 6.40, but it contained some unfortunate bugs. What software doesn't, right? So the first usable version was in version 6.4.2. So let's talk about the design. Under the hood, the metrics framework in Solr uses Dropwizard metrics library. This is a high-performance, very lightweight metrics library that supports several types of commonly used metrics. So, for example, we have the, I'm going to use this fancy pointer. Let's see if it works. Yeah. So we have the counter, which is a monotonically increasing counter, simply. So you could say, yeah, it counts the number of processed docs, beginning with this, with the moment when you started Solr and started indexing docs, right? Then there is a meter. Meter is a combination of counter and moving averages. And similarly to the system load average that everybody knows, it maintains 1, 5, and 15 minutes moving averages. So meters are used, for example, for reporting system load average. Again, it's not practical to log in to each box and check its system load average, right? It's much better to have an API to retrieve it. Meters are also used for measuring rates of requests. Another type of metric that is supported by this library is histogram. Histogram is basically a histogram of values. So histogram metrics collect values, for example, like request sizes or document sizes or I/O read sizes, and they put them into bins to try to approximate the distribution of sizes of values, right? But if all these histograms are exponentially decaying, so they keep the most recent 5 minutes of data. Another type of metric that is supported is a timer. Timer is, again, a combination, so you see that it gradually builds upon the other types of metrics, a combination of meter and histogram. So meter provides a counter and moving averages, and histogram is what I just described. So for example, we use timers for commit times, query times, and request times, because it's practical and useful to know what is the histogram of request times, but at the same time, we want to know how many, which we need a counter for, and we need a moving average to keep track of what is the most recent rate of requests. And finally, we have gauges. Gauge is an instantaneous reading of a value. So this value has no history. It's like the current heap usage, the current CPU load, the current free disk space. Where do we collect the data from? The data that is maintained in these metrics is collected on several levels. First, we have the JVM metrics, which is the GC, heap, threads, thread pools, class loading, and so on and so on. Then we have the JETI level metrics, which track the connection pools, thread pools, failed requests on the HTTP level, and so on. Then we have a container metrics. When I say container, sometimes referred to as a node, it's a core container component in Solr that is responsible for managing Solr cores. So yeah, container metrics include a number of cores, data paths, admin handler metrics, and so on. Then we have per Solr core metrics. So for each Solr core, there is a group of metrics that is independently maintained for each Solr core. For example, all request handlers now export request counters and timers, and some other metrics too. We have searcher and cache stats, replication statistics, index level timers. Basically, every other component that you can think of now can export metrics. And finally, optionally, we can include also and report aggregated Solr cloud metrics that are aggregated from several nodes across the Solr cloud cluster. These metrics are kept in registries. Registry is basically a glorified map, which is type safe. So there are metric groups for each major aspect of a running Solr instance. So we have a group for a JVM, for JETI, and node. As I mentioned earlier, it simply means core container, and for each Solr core. So we have one registry per group, but we have one registry for each Solr core, which makes sense because it's easier to manage these registry instances in the same life cycle as the life cycle of a Solr core. So if you delete or unload the Solr core, we don't want these metric registries hanging around, right? These registries don't provide any persistence. So if you restart your Solr instance, the accumulated metrics are lost. It's up to you to, if you want to track them over an extended period of time, it's up to you to accumulate them elsewhere. And more on that in a moment. Registry names are hierarchical because they reflect the structure of components in Solr. They are always prefixed with Solr dot. And if you don't like these names, you can override them using system properties, which is sometimes useful if you want to combine metrics from several registries into a single registry. Like, for example, if you want to track metrics for all Solr cores just in a single metric registry. So, for example, if you have a Solr core name like this, let me see, yeah. This is a Solr Cloud name. Solr Cloud tends to create these complex-looking core names. So we have collection 1 _ shard 1 _ replica and 3. Then the corresponding registry name is dot separated. You could say, yeah, that's a simple regex replacement, but it's not. It actually knows how these things logically relate to each other and builds this based on the logical relationships of collection to a shard to a replica name. So within these registries, we have groups of metrics. And again, metric names are arbitrary, but by convention, they are, again, constructed in a hierarchical way using dot-separated notation. So for example, request handler metrics strictly follow this naming here, that they begin with a category, which is one of the Solr InfoBean category names. Then we have the handler name or scope, and finally the metric name. So for example, we have the query category. Under query category, we know that this is the /select handler, which is the default query handler. And then we have the metric name, which is request times. It doesn't have to be such a short name. As you can see here, we have the update shard handler, et cetera, which tracks the particular counter that tracks the thread pool recovery executor. So if you combine all of this, you arrive at more or less a hierarchy like this, that you have registries, you have metrics, and metrics have individual properties. And metric properties could be as simple as an individual number. And this is what counters are. They just provide you with a single long number. But they could be more complex. Like, for example, timer. As I mentioned before, it consists of several parts. It consists of a counter, of moving averages, and of a histogram. So all of these properties are available. Some of the metrics don't correspond to either counter or timer or meter or whatever. They are just exposed data structures, internal data structures from Solr. So for example, we have metrics that correspond to caches. And they have properties that correspond to cache properties, like total size, entries count, and actually you can retrieve individual entries as well. Or these metrics can represent arbitrary maps, like, for example, system properties. You may wonder, okay, but system properties is a huge chunk of data. I don't want to retrieve all system properties for every call. Well, using the admin metrics handler, I will show you in a moment that you can retrieve actually not only individual metrics, but also individual metric properties. So if you just want to check what is the actual value of system load average 5-minute rate, you can do it in a single call, and it will return a single piece of information. So let's talk about the implementation. Picture is worth 1,000 words. So we see the core container here, which is the component in Solr that is responsible for managing Solr cores. And we have several Solr cores here. Let's say that they represent collections like collection 1, collection 2, collection 3. And core container creates a Solr metric manager. Solr metric manager is a central component that is responsible for managing all registries in Solr. And it's also responsible for managing metric reporters. More on that in a moment. So we can see that there are some global metric registries, Solr JVM, which is global because we are running everything in a single JVM, and Solr Jetty. But we also have a Solr node that tracks metrics that are specific to core container. And then we have several registries, as many as there are Solr cores, 1 registry per core. These funny little red boxes, they represent something that is called Solr metric reporter. This is the component that is responsible for actually reporting these metrics to external systems, which is quite important because some systems don't work well with the pool model. Using the admin metrics handler, which is shown here, you can access all of these metrics, but you have to actually pull them. So you have to know in advance what the metrics are, and you have to pull them. But using these reporters, you can use the push model and push selected metrics to external systems. External systems could include like Logger, so this way you can create files if you have an external system that is bent on working with just files, right? You can use JMX or Ganglia or Graphite. A few words about this admin metrics handler. Using this handler, you can access basically all metrics. It doesn't mean that you have to retrieve all metrics in each call, because there are flexible selection criteria that you can use to select what metrics you want to retrieve and even what properties of these metrics you're interested in. So you can select registry by group using this Solr info bean group property. So for example, you can use Jetty, Node, Core, etc. Or you can use this full registry name, as I showed before. For example, Solr Core Collection 1. You can filter metrics by a list of prefixes or regexes. And you can also retrieve only some properties, not all of properties of a metric, especially if it's a bulky metric like system properties or caches, cache metrics, etc. In 7.1, we actually added a special syntax for this using the key parameter, where you can specify a fully qualified name of metric starting with the registry through the metric registry name, metric name, and the property. So this is useful if you want to retrieve just a single property. How does it look in practice? Well, here's the request that I made to Solr admin metrics. And I selected group core, which represents all Solr cores actually present in this Solr instance. And I wanted to retrieve metrics that start with the searcher. And you can see that the response I got is, well, in this case, I had two Solr cores. So I have an entry that corresponds to Solr Core Collection 1, Shard 1, Replica, and 2. And I have another entry here, Solr Core Collection 1, Shard 2, Replica, and 5, right? I collapsed some of these sections, otherwise it would be minuscule. So, and here we have metrics that all start with the searcher prefix. So yeah, it worked. And inside, for example, the timer, we have the count and moving averages, right? And histograms. So let's talk a little bit about the configuration. Metrics collection is already happening. So if you're running Solr 6.4 or more recent, metrics are collected anyway, even if you don't use it and even if you're not aware of it. Why? Because they provide so much benefit, but the overhead of collecting these metrics is pretty minimal. It's in the order of microseconds per requests, and the total amount of memory that is consumed by these metrics is in the order of kilobytes. Currently, Solr maintains roughly around 170 metrics per Solr core. Altogether, including core container, Jetty, and JVM metrics, it amounts to roughly 250 individual metrics. There's a new section now in Solr.xml where you can configure what kind of metrics you want to report to external systems, which is the reporter configuration. You can also specify custom metric implementations if the implementations that are provided with Solr are insufficient for some reason, and I will talk about some of these reasons later on. And you can also specify some debug information, configuration, like, for example, you want to turn on some really low-level metric collection. So I mentioned this already a couple of times, and probably you're already curious what the reporters are. Reporters are simply components that extend Solr metric reporter. They are configured in this new section in Solr XML under Solr metrics reporter. And they are the components that simply report selected metrics, or all metrics, if you are so inclined, to external systems, or they write them to files. There are several implementations provided out of the box for back compatibility, and yeah, we have the JMX reporter, which, unlike the JMX component in earlier versions of Solr, provides a fully hierarchical view. In older versions of Solr, there was a way to hook up a JConsole and see and use the JMX reporting. But that view was sort of all jumbled together, you know. It didn't have any hierarchy, so it was sort of hard to figure out at a glance what is what. This time, we did a fully hierarchical view. Other types of reporters that are shipped with Solr include Ganglia, Graphite, and SLF4J. And the API for adding new types of metric reporters is really easy. So if you have some odd system that needs its own format, you should just go and implement it. Actually, one of my colleagues, I don't know if he's here, Varun Thacker, already implemented one that pushes these metrics to an InfluxDB database. The instances of these reporters are created for each metric registry. This way, we can control the lifecycle of a reporter together with the lifecycle of the metric registry and the lifecycle of the corresponding Solr core. So the example of Solr XML with this configuration, we have the Solr and the metrics section, and we have the reporter. This reporter is named global because it doesn't specify neither group or registry name. So this means that it will be created for every existing metric registry. And in this case, it's exactly what we want, because we usually want to export every possible metric using the JMX reporter. The other reporter that we've configured is per core. So it specifies that, yeah, I want to deal with core type registries, right? And it uses SLF4J reporter, which simply dumps the names and values of metrics into a selected logger, in this case metrics logger, every 60 seconds. There is also a section in this Solr XML file that deals with advanced configuration. As with every software, we have some limitations, right? So it's good to be aware of the limitations that you have in the default settings and the default implementations of metrics that Solr comes with. So for example, the default histogram and timer in Dropwizard metrics uses exponentially decaying reservoir, which is used for sampling the incoming values. But the thing that is not widely advertised in the API is that it assumes that the values that you put into this reservoir more or less follow the normal distribution. What happens if your distribution is skewed or completely different, like in this case? Well, bad things happen. Because it's very easy that this reservoir in such case may completely lose these very important outliers. I don't know why the picture is cut off here, but there is another outlier here. But this illustrates the problem very nicely. You're going to lose this outlier. Why? Because this reservoir is of limited size, and by the very nature of random sampling, these values in the reservoir are randomly replaced. And if the update rate is high, but the period at which you take snapshots of this histogram is much longer, then it stands to reason that some of these values have been already replaced by the time you took this snapshot, right? So this type of histogram implementation may lose critical outlier information. So you should be aware of that when you're facing the high rate of updates. On the other end, the extreme, if your rate of updates is very, very low or none, this histogram is only updated and decayed whenever there's an update. If there are no updates, it's now decayed. So the values in the histogram become stuck. So in a sense, it gives you a false reading because it gives you, okay, currently the last 5-minute average, which is what it's supposed to report, reports that I have, this or that P95 value, right? 95th percentile value. But you know for sure that the main router was down for the last hour, so it's impossible. How to deal with that? Well, that's what the advanced configuration section is about. You can specify a custom supplier for the histograms, or at least you can adjust, you can tweak the configuration parameters of these default reservoir implementations. So, for example, in order to solve this issue with EDR, exponential decaying reservoir, you can specify a different reservoir size. If the reservoir is much larger, then the likelihood of losing important outlier information is less, right? Or you can specify a different reservoir implementation, and Solr comes with several implementations, alternative implementations of this, each with its own trade-offs. So please read the docs. Some very smart people came up with their own histogram implementations. There is a project which is called High Dynamic Range Histogram, HDR histogram. And there is a guy, Vladimir Bukhtayarov, that wrapped this into an API that is compatible with Dropwizard metrics and implemented sort of decaying, exponentially decaying reservoir, but which uses internally this high dynamic range reservoir. So you should take a look at this and see if it fits your needs. But that's what this section, Solr metrics suppliers, is for. How does it look like? Well, in this case, I just wanted to use a sliding time window reservoir, which is one of the implementations that comes with Hail or Dropwizard metrics. And I wanted to keep the window that is 300 seconds long, which more or less corresponds to the 5 minutes exponential decaying reservoir. That is the default. Let's take a look at some of the example outputs. So I mentioned before that the JMX reporter right now produces a nice hierarchical view of all the metrics. So we can see starting from the top, we have the prefix core, which is the group, and we have collection 1, shard 1 and shard 2, and under shard 2 we have replica N5, and here we have all the metrics grouped by category, right? And we have, for example, search and new timer. We have, and the attributes of the timer include these histogram count and moving averages. I mentioned before that you can export this data to, for example, graphite. So here's an example how this data looks in graphite. I don't know if you can see this. These letters are tiny, but it shows some of the metrics from the OS group, which are located in Solr JVM metric registry. So all of this data was exported and pushed out to an external graphite instance. Another nice view of these metrics is this, because you can see we can track what kind of index merges are occurring currently, which sort of corresponds to what is the current I/O load of a Solr instance, right? And for a while, because of the indexing activity, that part of it is visible here, we've had one major merge running. If you hit the admin metrics API directly, you get much more details about index merges, like, for example, how many documents are involved in each merge operation. But here you see, it's interesting, because we are running concurrent merge scheduler. For a while, we had two concurrent merge operations running. So this is useful for troubleshooting and for actually seeing, probably for the first time, what is the actual dynamic behavior of the system under load. Yeah, and the most sexy view, the SLF4J view, which, as I mentioned before, the SLF4J simply dumps the selected metrics, metric names and metric values to a logger. How you format this logger, it's up to you. It's just standard log4j configuration or whatever logger you're using. So what does the future hold for this API? We definitely need to add more configurability. Currently, for example, if you select a histogram supplier, it's global for every kind of histogram that is used throughout Solr. But not every component is alike in Solr. So, for example, there are components that are heavily loaded that experience a heavy rate of requests, and they could use a different histogram implementation than the components that are rarely or ever hit. So we definitely need better defaults for these reservoirs in order to avoid these limitations of the exponential decaying reservoir. Metrics already are and will become even more important for the autoscaling framework. And Shalin, who sits here, will talk about autoscaling tomorrow, and I strongly encourage you to attend his session as well. So the autoscaling actions, the way how the cluster will be rebalanced and reshaped according to the current state of the cluster will be largely based on metrics, because this is the mechanism to measure the actual behavior or the actual state of the cluster at the moment. Ultimately, at some point in time, we may want to use the metrics for some sort of feedback control of Solr clusters. And we've already started working on this. This depends on a modeling and simulation framework that we started building in Solr 11.285. So, to summarize, metrics are a very lightweight but very detailed insight into all of the nooks and corners of how the Solr instance behaves. Metrics are provided now by most, if not almost all, Solr components, and it's very easy to add new metrics. There are already some Jira issues for adding new metrics to some components. These metrics can be accessed directly using the admin metrics handler, but they can be also pushed out to external systems or to files. Several popular systems are already supported, and it's very easy to add new types of reporters. Metrics also provide key data for the operation of Solr Cloud autoscaling. So my question to you is, how do you want to use metrics in your deployment, in your troubleshooting? Now you have the knowledge that this system exists and what kind of information it can provide you. I believe we have a few minutes for questions.
Does the memory usage change as you start configuring different reporters, like JMX, for example? Is the memory usage sort of like standard?
The question was whether the memory usage changes when you configure different reporters. I would say minimally, because the reporters are not actually, they don't actually copy this information, This information is already held in metric instances that are kept in metric registries. So what the reporter does, it simply transforms these internal metric representations to external, like JSON maps or whatever. I don't know. That's a very good question. Please file a Jira. I was thinking about adding this implementation, but first I wanted to make sure that the basic framework works as expected, more or less. But yeah, that's a very good point, that there should be a functionality, should you wish to do so, to reset the metrics and start from scratch without reloading Solr core. So please file a Jira. Yes.
Did any of the underlying Luciding code, was that instrumented, or is it just the Solr level?
Well, we've instrumented index searcher and index writer. There is an optional low-level instrumentation of, or there was at least for a while, of directory to track the I/O operations. But this is where the problem appeared, that even though this metrics collection mechanism is very lightweight, it takes microseconds per call, it's still, if you're talking about I/O operations, you have millions and millions of these operations, and it adds up. So it resulted, because it was turned on by default, it resulted in a significant performance hit. So yes, it is possible to do so. We've consciously removed this once it was added because it had too great an impact. But maybe we should, restore it, but put it, under a configuration parameter that, it's turned off by default. But yes, it's quite possible to do so. Well, reporters are sort of asynchronous. They don't, they're not, well, let me backtrack a little bit. It's really up to you how you implement the reporter. The reporters that are already implemented, they use their own thread pool, their own scheduler, so they don't affect the primary operation of Solr. If there is a problem, with that you have a slow database at the other end where you're pushing the metrics, only the reporter will have this problem, and not any other part of Solr. The question is whether you can add your own report metric, metric type or metric value. Well, as long as you use one of these existing metric types like counter, timer, meter, gauge, etc., it's very easy. It's just like one line of code.
So there's a lot of metrics that you can get. Is there any guidelines on which ones of these you should watch?
Yes. So. Yes, yeah, it's a complex topic. I'm sure people. Yeah. So let me just repeat the question so that it's recorded. What metrics specifically should you monitor, right? Or what metrics you should use to figure out what is the state of the system, however you define it? Well, that's where the problem lies. It's how you define how you define the health of the system. Is it a system load average, or is it the number of requests for the select handler, or is it the histogram, like P95, 95th percentile, that is most crucial to you? Then that's the metric that you should watch. As I said, there's roughly like 250 metrics to check. So yeah, it could be daunting at first, but I'm sure you will quickly figure out which are the most interesting ones for your use case. Oh, yes. Exactly. I mentioned this before, that we've instrumented, we're actually using the management MX beans, right, which exposes all the details of GC operations. So, yeah, this is already exported as metrics. Right. In previous versions, yes. In previous versions of Solr, you used to configure the JMX. Sorry? Oh, yeah. The question is, where's the configuration located for the metrics right now, for the JMX metrics right now, as compared to the previous versions of Solr? So in previous versions of Solr, you would configure JMX in Solr config XML for each core, right? Well, this has been deprecated right now. Well, actually in 7.0, it's not supported anymore. You're supposed to configure the Solr JMX reporter in Solr.xml. And there, you can configure whether you want to use it just for Solr cores, or whether you want to configure it for other types of registries as well, which was impossible to do before, because before we didn't, we weren't collecting statistics at the container level, right? Only at the Solr core level. So you're already getting much more information this way. But to make it easier for users to switch to this new configuration, we're automatically adding this JMX reporter whenever we detect that there's an active mbean server. So if you start your Solr using bin/Solr and with JMX options, right, to turn them on, then this will automatically turn on the JMX reporter for every existing registry. I believe we ran out of time, right? Thank you very much. I'll be available for questions.